In a stunning development, scientists have recently made a discovery that could redefine our understanding of one of the universe's most mind-bending enigmas. At the very center of these celestial powerhouses known as black holes, researchers have uncovered something so astonishing and unnerving that it challenges the foundational principles of modern astrophysics. What lies within these mysterious voids is both extraordinary and terrifying, a revelation that beckons us to rethink everything we thought we knew about the fundamental nature of space, time, and gravity. Today we take you on a journey into the concealed heart of a black hole, unveiling secrets that have eluded humanity for centuries. For those fascinated by space and the cosmic phenomena that govern our universe, make sure to stay informed by subscribing to our channel. Show your support by liking the video, sharing it with others who are equally captivated by the cosmos, and turning on the notification bell so you're always updated on the latest discoveries from deep space. Black holes remain among the most fascinating and baffling entities in the known universe. Their existence was first theorized by the brilliant mind of Albert Einstein through his groundbreaking theory of general relativity. According to Einstein, gravity is not a conventional force in the way we typically think of push or pull. Instead, it is the manifestation of how massive objects warp the very fabric of spacetime around them. This warping effect is what causes smaller objects to be attracted to larger ones, not through an invisible tether, but by the bending of space and time itself. The curvature of spacetime essentially creates a gravitational field, with its intensity depending on the mass and energy of the object causing the distortion. The more massive and energetic an object, the greater its gravitational pull, and the more it bends the surrounding spacetime. Black holes, formed from the remnants of collapsed massive stars, are at the extreme end of this curvature. Their immense mass is compacted into an extraordinarily small volume, creating a gravitational field so intense that it produces a deep well in spacetime, one so steep that nothing can escape its grip. This leads us to one of the most crucial aspects of a black hole, the event horizon. Far from being a physical wall or surface, the event horizon is a notional boundary, a limit at which spacetime curves so sharply that escape becomes impossible. If any object, including particles of light, crosses this invisible boundary, it is lost forever to the depths of the black hole. Light, which normally travels at an astonishing speed of approximately 300,000 kilometers per second, cannot overcome the gravitational pull once past this point. This invisible perimeter forms a one-way passage into the abyss. Now, imagine holding a flashlight. When you turn it on, light travels outward at its typical speed, illuminating the space around you. But if you were to somehow stand inside a black hole past the event horizon, no matter how fast light tried to escape, it would fail. The escape velocity inside that region exceeds even the speed of light, rendering the concept of illumination, communication, and even time itself meaningless according to our current laws of physics. This phenomenon is what makes black holes appear completely black. They emit no light that we can observe. Deep within this boundary lies the singularity, the core of the black hole, and the most enigmatic region in the cosmos. The singularity is thought to be a point where all the black hole's mass is concentrated into an infinitely small and dense space. It represents the ultimate gravitational collapse, where spacetime curvature becomes infinite and conventional physics breaks down entirely. Our scientific understanding simply does not extend to the behavior of matter and energy under such extreme conditions. It's as though the known laws of the universe switch off, leaving us grappling with equations that no longer apply. To truly comprehend how black holes come into existence, we must journey back to the life cycle of massive stars. These stars are monumental energy factories powered by nuclear fusion reactions occurring in their cores, the same process that fuels our own sun, where hydrogen atoms fuse together to form helium, also sustains these massive stars. This fusion releases tremendous amounts of energy, which radiates outward and balances the inward pull of gravity, allowing the star to maintain its shape and radiance. As long as the star contains sufficient hydrogen fuel, this fusion process continues and the star remains stable. However, stars are insatiable in their hunger for fuel. Once the hydrogen in the core is exhausted, the star begins fusing heavier elements such as helium, carbon, and oxygen. Each new element fused yields progressively less energy than the last. To maintain equilibrium, the star must burn hotter. and faster, eventually reaching a tipping point when it can no longer generate enough energy to counteract the pull of gravity. The star undergoes a catastrophic collapse. This implosion results in a supernova, a dazzling explosion that marks the end of the star's life. What remains of its core, however, is not destroyed. Instead, it is compressed into an incredibly dense point, a black hole. This point, or singularity, becomes the beating heart of the newly formed black hole. In a historic leap forward, astronomers recently directed some of the most advanced telescopes ever created toward a supermassive black hole nestled within a galaxy approximately 800 million light-years away. This titanic black hole exhibited behavior that was as awe-inspiring as it was perplexing. Like other black holes, it fed on matter that strayed too close. As this matter spiraled inward, it was compressed and heated to extreme temperatures, reaching millions of degrees. This resulted in the formation of a bright, swirling ring of high-energy gas known as a corona. As the corona glowed with intense energy, it emitted powerful bursts of X-rays, what scientists refer to as X-ray flares. But something remarkable happened. Instead of vanishing into the black hole, some of these flares appeared to reflect back, almost like echoes. These unusual X-ray bounces came from behind the black hole and were bent around its colossal gravitational field before making their way to our telescopes. This incredible phenomenon defied expectations and offered an unprecedented glimpse into the physics of extreme gravity. This event marked a watershed moment, the first time light was detected from within the region just beyond the event horizon. The discovery confirmed yet another of Einstein's predictions from his theory of general relativity, that light can indeed be bent by gravity. It was a cosmic revelation that strengthened our understanding of how massive bodies influence the behavior of electromagnetic radiation. This monumental observation was made possible thanks to the collaborative power of several cutting-edge instruments. The European Space Agency's XMM Newton telescope, NASA's NuSTAR Observatory, and the James Webb Space Telescope all contributed data. Together, these instruments captured a stunning light show of X-ray flares over several days. When researchers analyzed the data, they noticed that some flares arrived later than others and carried different energy signatures. This anomaly hinted at a deeper mystery. Why were these flares delayed, and what caused the variation in their color? Further analysis revealed that the delayed X-rays were the result of what scientists call light echoes. In the vicinity of the black hole, swirling gas and dust form an accretion disk. This material heats up due to the black hole's extreme gravitational pull, generating powerful emissions of X-rays and radiation. Some of the emitted light was pulled around the black hole by its immense gravity and reflected off material on the far side. These echoes traveled a longer path to our instruments, arriving slightly later than the original flares. The significance of this finding cannot be overstated. It confirmed in real observational data the warping of light paths predicted by Einstein over a century ago. Not only does this discovery deepen our understanding of black holes, but it also validates one of the most fundamental principles of general relativity. What do you think of this extraordinary cosmic revelation? Share your thoughts in the comments below. If this voyage through the mysteries of the universe intrigued you, don't forget to hit the like button and subscribe to our channel for more insights into the cosmos. Thank you for joining us on this journey into the heart of darkness, and stay tuned for the next chapter in our exploration of the universe.